Welcome to another tutorial on Matlab. In this particular tutorial, we are looking into the concept of plant modeling and how to create a plant model in Simulink or Matlab. In the previous tutorials, we have seen how to develop models in Simulink. In this particular tutorial, we will be considering a electrical circuit, which is a series RLC circuit, and through that we will be creating the plant model or the system model in MATLAB scripting. So considering this equation, so we have a voltage source V and we have the series resistor R and we have a capacitor C which is connected in series in the circuit, and we have an inductor L. So when the voltage is being provided here, then the current will flow in this particular circuit, and different components will behave differently. Like resistor will dissipate the heat, capacitor will store the energy in the form of charge, and inductor will store the energy in the form of magnetic field. Then we can apply a KVL. So it is basically Kirchhoff's voltage law. So KVL. Using this KVL, it is considered that in a loop. So suppose we are starting from here and ending here in the same point. In a loop, the overall voltage should be equal to 0, or the sum of overall voltage. And it is equal to like voltage across resistor. So we are the voltage across the capacitor plus the voltage across the inductor should be equal. So this is the one that we will be getting, and from this we can derive this particular equation. So all these two terms will be moving on the left hand side. So considering this, we have the system equation now. So here you can see like, so this is the voltage across the inductor. So voltage across the inductor equal to L di by dt. So as it is L di by dt, the voltage across the inductor, so we can make it like di by dt equal to 1 by L into V. So this is the voltage across the inductor, and this part is representing the voltage across the inductor, and this is 1 by L. So that is how we form the equation 1. Then we already know that C dV by dt equal to I. This is for capacitor, basic equation. So we just move this C here downside. So it will be like dV by dt equal to I by dt, I by C. So this is the second equation. So using these two equations, we can create our state space model. Why we are considering the current and voltage into the dynamics, because these are the two things that changes in the circuit, and that we need to monitor because that is the only dynamic part in the system. So that is why we can have written it like di by dt equal to this part, whichever is written here. So that is formed in the form of matrix, which is then yeah, dvc by dt is represented here, which is this part of this particular equation. So if you multiply it and add it, then you will get all these two equations. Now, suppose you want to know the voltage across this capacitor, then in the output equation, you can mention it in the C matrix. So basically, this is the C matrix, and the common form of output equation looks like this: C into X, which is the state matrix, state vector, plus D into U, which is the input matrix and input to the system. This is dx by dt equal to ax plus bu. So these are the state equation, and using this state equation, we will be developing our MATLAB script. which represents a plant model for the particular circuit, and that will be doing in the upcoming video. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. It will help us to improve your experience of learning MATLAB in this channel. Have a great day ahead.